In the world of Cisco networking, whenever you hear top down or bottom up, you're referencing the OSI model. In this CBT nugget, we're going to go ahead and do a little OSI model review, but then most importantly, we're going to go ahead and examine what Cisco recommends for us to do from a design perspective, and that is design thinking about the top of the OSI model and working our way down. So obviously, to get things started in this nugget, we need to talk about what exactly is the top-down design approach. What does that mean? We'll take a look at a great tool that you can use when doing network designs, and that's called a decision table. We'll talk about how you can really scope the network design, and finally, we'll wrap up by walking you through a sample design process. For example, how do you test that your design's going to work? And what do you give to your customer? And remember, that customer could be your boss. So, what kind of things would you turn into that customer to really walk them through your network design? Now, remember, when we say top down, we're talking about, of course, the OSI model. Yes, the beloved 7-layer OSI model. So, when we say a top down network design approach, we're saying thinking at the highest level of abstraction, right? We're thinking about the applications and the services that we want to bring to the network, as opposed to thinking about, okay, what are the exact physical specifications that this network is going to follow? It's really, really interesting that designing networks works so great from a top down approach because what do we typically do when we troubleshoot networks? That's right, we start at the physical and we work our way up. Yeah, so when it comes to supporting a network, troubleshooting a network, we love to start at the physical, but I want to really start guiding you to thinking about the highest level of abstraction and working your way down when it comes to network design. Now, why do we do it? Why do we recommend that top down design approach? Well, first of all, it really focuses on the organization's requirements. Hasn't that been a huge theme for us as we have moved through even these introductory CCDA titles? Yeah, the goals of the organization, what the organization wants to accomplish, that should be our focus. And when we start the top down design approach, it directly addresses those high level organizational goals. You know what it also does? It gives a great overview very early on to the customer of exactly what we're going to do for them. A great example would be a voice over IP, a Cisco Unified Communications Network. We can really start painting a picture for them easily at a high level instead of focusing on the details, instead of talking about software versions and router versions and all this stuff. We paint a great picture for them early on of exactly what types of services they can achieve with the solution. And finally, it typically, if we do it right, is going to provide a design that is appropriate for the current requirements and also a design that should address the needs of the organization in the near future. So, the top down design model is definitely something that we want to consider. Now let's talk about an awesome tool that's going to help you out with your network design and could potentially help you out when you have to decide anything major, and that is a decision table. Here's what we do to draft decision tables. We go ahead and we identify what are going to be the major decision points that we need to make in this network design. Classic example, what interior gateway routing protocol is the organization going to run? Okay? Yeah, that's a prime classic example. Are they going to do EIGRP or do they have a mix of vendor routers so they can't do EIGRP? Is RIP sufficient? Is OSPF better? Should we do ISIS? We'll take a look at an example here of choosing what routing protocol is right for a company. So we identify these major decisions we have to make. We then go ahead and collect all the options. I just rattled off a bunch in our example, right? ISIS, EIGRP, OSPF. heaven forbid, RIP, and then we go ahead and we create this table. We create the table and we include possible options and we add parameters or properties of each of the specific options. And again, I'll show you an example here in a moment. And then we go ahead and we match the requirements of the organization against this table. And of course, why we're doing all of this, it helps us decide the perfect option for that organization's network design. So what does one of these decision tables look like? Well, of course, let's use that example I keep referencing, and that is choosing the appropriate IGP for an organization. So of course, across the top, we list EIGRP, ISIS, OSPF, RIP version 2, and down the side, what you do is list all the possible parameters, right? Brainstorm on this. Okay, obviously, size of network, expertise within the organization. Does it handle non Cisco equipment? And then you fill out the table. So, for instance, on size for EIGRP, well, it can be a big network. For size on ISIS, it can be a huge network. For size on OSPF, it can be a huge network. And for RIP version 2, of course, it's going to be limited to a small network. How's the company on experience really when it comes to these routing protocols? They may be an A plus on EIGRP. They may be an F on ISIS. They may be a D on OSPF. They might be an A plus on RIP version 2. Non-Cisco equipment, they don't have any. So if they're an all Cisco shop, they're fine with EIGRP, or obviously would put an X in the table because they wouldn't be fine if they had non-Cisco equipment. You get the idea. And then all of these are going to be fine with non-vendor equipment. You then take their particular parameters and you simply match them against your decision table. They don't have any non-Cisco equipment. They have a big network. Their engineers are at an A plus level, and you say EIGRP is the right choice, for example. Again, I've given you a small decision table here. We could go on this decision table, right? Like variable length subnet masking support. We could look at things like the overall feature set on the routers that we are recommending for the organization. So don't limit yourself on the decision table. Make it big, make it vast, and that'll help you arrive at that appropriate decision. And perhaps we should have mentioned it earlier on, right? But what is the scope of the project? This is something that is definitely critical that we need to make sure we keep an eye on throughout the network design. I mean, is this company really just interested in a new network service like wireless or voice over IP or video over IP? Are we just adding a new network area to an existing network infrastructure? Or is this one of those rare moments where we get to rip and replace? That's right. Take the existing infrastructure that they have, completely remove it, sell what we can for scrap, and then replace the existing network infrastructure, former network infrastructure. So always keep in mind the scope, and you don't want to go outside of this scope. And by the way, when it comes to scoping a new service, because that's so common these days, you have to really decide, all right, if it's voice over IP that we're going to add to this infrastructure, what does that really mean? I mean, in some organizations, it's going to mean just minor tweaks to the existing infrastructure, but in other organizations, that's going to be a massive scope. I mean, if they have no quality of service and they lack devices that can even do quality of service, then adding voice over IP has a tremendous scope. Now, what's the process that we follow with the design for the customer? Well, what we do is we go ahead and we describe each step, obviously. So they want to roll out voice over IP. You indicate to them, okay, look, first step, okay? Let's describe the first step. We need to go ahead and upgrade this equipment to support quality of service. You're going to reference them to the design document that you create that says exactly why they need to do that. So they're going to be clear cut on exactly what is the objective. Then you're going to give them guidelines, obviously, on that step. So with something like quality of service, hey, it's not new. This is pretty spelled out how we have to go about this process for voice over IP. Then what you do is you guide them through rollback. Always do this step. Always make sure. And by the way, this is going to be not like common nature, right? You don't want to tell them, oh, by the way, when this blows up, you got to do this. That's not going to be in your nature to do that, but we need to do that. There needs to be a rollback plan in place for whatever might go wrong with the design that you're suggesting. And always, always make sure they understand the time consequences, especially for rolling back. So, look, we're going to upgrade these certain devices to make sure they can do the appropriate level of quality of service for voice. If this blows up on us, our downtime will be X. And the time to restore the network to its functionality will be Y. So we need to make sure they're clear on the process, the guidelines for that process, and what we will do in the event of an emergency, and exactly how long that will take. Now, I've got great news for you. You've got a secret weapon when it comes to ensuring your design knocks the customer's requirements out of the park, to use a baseball analogy. These actual two secret weapons that you possess are pilots and prototypes. Now, for the CCDA exam, it is imperative that you understand the not so subtle difference between these two entities. With a prototype, you build and prove your concept in the non-production network. So you go to your own network and you build a prototype of what you want to do for them, and you make sure your design works. Guess what? A pilot is in a small area of their production network. So that's the simple difference. A prototype, we build it in what we call a sandbox. It has no interaction with their network infrastructure whatsoever. A pilot is in a segment of their production network. You can see how that would be great, right? We do a prototype. We say, all right, in the lab, this worked great. Now let's try a pilot. Let's go to a segment of their organization, maybe the Tampa, Florida branch, and we're going to test in the Tampa, Florida branch this QoS implementation, for example. So what did we accomplish in this nugget? Well, we took a look at the top-down design approach, and we said, boy, doesn't it make sense? Even though intuitively we love to go bottom up for implementations and for troubleshooting, doesn't it make sense to start up at the most abstract layer of the OSI model when it comes to network design and work our way down? We took a look at decision tables, and we saw how they're a great mechanism for taking the requirements of an organization and making the appropriate decision based on those requirements. We talked about the importance of scope and how we really need to look at, okay, just how big of a design is this? And then we walked through a sample process for design. We took a look at things like a rollback procedure and giving the customer an estimate on times when it comes to all this implementation. And finally, we took a look at the power of pilots and prototypes and made sure we understood the key distinction with those. And that was simply, is it in a production network or is it in a non-production network? Remember, the pilot is in the production network. Well, I hope this has been informative for you, and I'd like to thank you for viewing.